So we'll start here, practice session now. What to practice now we are starting. So 11 it is, around half an hour I'll give the short notes for you. 11:30 to 1:30, maybe 2 hours it will take to solve the questions completely. By 1:30 we'll reach the concept, total practice session. Okay. So let us start our journey first. What questions we can do? So we have EC book and electrical book, but one book only I do it. Okay. Either electrical or EC. I'm taking a choice of EC book for this because electrical book I have solutions for it. If you want I can give solution because only 2-3 questions in the starting are different, not matching with your EC book. Remaining questions are same. So let me complete any one book. Okay. Let me complete EC book where you have good number of questions where the same questions are repeated in electrical book. Okay. Feedback amplifiers I'll go for electrical book for you. Yes, alternate I'll go for electrical. Today class EC book question numbers I'm writing. Let's see. So just I'll concentrate on EC workbook. What questions I can do with the yesterday class content? Let's see the question numbers first. This is chapter number 7 we are talking. Chapter number 7, my friends. The electrical EC book I'm following the order, which is called op-amps chapter it is. Op-amps and purified chapter it is. In this what questions I can do here is start the question numbers. We have a lot of questions now to do. Question 1, question 2, question 3. Please note down the question numbers. Question 4, question 5, question 6, question 7, question 8, question 9, question 10, question 11, question 12. Leave the 13th question. Question 14 you can do it. Question 15, question 16, question 17, question 18, question 19, question 20. Other questions are some other applications there. Question 23 you can do it according to our subject knowledge. Question 25 you can do it. You can see how much weight is for this content. A lot of questions are there in competitive exams. So question number 33 I can do it with our yesterday class knowledge. 34 you can do it. 40 you can do it. 41 you can do it. 42, 43, 45, 48, 49, T3 and T4. So really speaking, this many number of questions are there, which we can finish the concepts behind our amplified designs and op-amp basics. Whatever we studied, how we'll apply the concept in this questions is important. These are all questions I'm going to do the solution step by step. Okay, you can see each and every question, how much we have learned the content, how I use it is a practice now. So take this one. First my job is before starting this practice game, first we have to recollect the total content, whatever I said from starting to ending. One time I'll give the short notes for you so that it is very beneficial for you to complete this problems easier now. I'll give a short techniques. Whatever we studied till now, make a short notes. Just within 20 minutes we'll finish. By 11:30 we'll start the practice. Very good number of questions are there today to cover this topic. So please write down. Let's start writing some short notes from starting to ending what we studied in the yesterday class. Okay. Just simply copy that numbers. Copy that numbers. Okay, quickly I'll write the points what we studied yesterday class. Okay, good. Let us write the short notes for this topic. Short notes. So recollect the points what I said yesterday. Some basic points I'm teaching for you. First point, point number 1. What are the important points here we studied in the class is? The first point, open loop, op-amp will work in open loop op-amp will work in non-linear region if AD is high. AD is nothing but open loop gain. So this is the rule number 1 I said. Okay, and you take this as A point. As a B point I'm writing open loop op-amp will work in linear region if AD is low. So this is about the situation. So one is non-linear it can work, one is linear it can work. I'll underline these points, yesterday observations. Non-linear region when AD open loop gain is high. So it will work in linear region open loop op-amps if AD is low. So these are the golden points yesterday we discussed. And C point, comparator principle will be used in open loop op-amp. What do you mean by comparator is V plus is not equal to V minus. This is another interesting point we learn. So comparator principles we can use. So these are about in your basic class I studied this first concept. Open loop op-amps main concept is this. So take it as a good points which will make you fast to recollect. So this is about open loop analysis. The second topic, positive feedback op-amp will work in non-linear if AD is high or AD is low. So your open loop gain can be high or can be low. No problem. Positive feedback op-amps will always work in non-linear because my gain of positive feedback is not AD, it is AF. So my AF is always greater than, your AF will be always greater than your AD. So because of this principle, so whatever may be the gain you have, low gain or high gain, my closed loop system gain will be high always in positive feedback systems. So due to that reason, it is saying that I never work in linear region like open loop systems. It will work only only in non-linear. If AD is high also, AD is low also. This is about the positive feedback analysis. So in this concept also we have studied. You take this as A point. So B point is comparator principle will be used. Comparator principle will be used in positive feedback op amp. Positive feedback op amp. Why? Because V plus is not equal to V minus. Here also we have the same theory. V plus and V minus both are not same. So comparator principles we use in positive feedbacks. So this is my second observation in the class. Concept number 2 is completed. You note down quickly when I'm writing, please note down because I have to teach the revision, I have to do it, and again I have to do number of questions. So time is very important. So please note down it parallelly with me. Okay? Because I'm not writing very fast. Slowly I'm writing, so you just complete off. When I move this slide, you must be ready to complete this notes, short notes. So point number 3, A point. Point number 3, A. Negative feedback op amp will work. Negative feedback op amp will work in linear region. Negative feedback op amp will work in linear region if AF is low. You can see here, closed loop gain should be low. Then you will be under linear region. Here also we have two constraints. Negative feedback op amp will work in non-linear also. They can work in non-linear also. But if AF is high, here closed loop gain should be low and high concept. Because AF is in my hands. Because the gain is nothing but a combination of resistors, which is minus R by R1, 1 plus R by R1 resistors. If you increase more and more, gain also can increase. But if you increase more gain, closed loop gain, negative feedback systems will go to non-linear effects. That's why we have to control ourselves. We have to reduce the gain according to the design I said. So we have two issues again here. Negative feedbacks can go to linear, they can go to non-linear. That's why always closed loop gain should be less, we have to keep, and here open loop gain should be high, we have to keep in the first case. First case, open loop gain should be high. Last case, we have to keep, closed loop gain should be low. Last point. C point. Virtual ground or virtual short principle will be used in negative feedback circuits, because V plus is equal to V minus. This is correct when AD is high. So virtual ground theory is acceptable. But here also there is a condition. V plus and V minus should be same. When AD is high only this rule is valid. And we have V plus is not equal to V minus when AD is low. So these are the beautiful things which we have been studying in our yesterday class. All these things you can see as a short notes to practice. So V plus is equal to V minus when AD is high. V plus equal to not equal to V minus when AD is low. And we have used the concept of virtual short in negative feedback circuits. So this completes the package of my basics, what we studied in our class in the basic point of view. So these are the 3 points we should never forget in our life for op amp design part. Okay? So please complete it. In the next slide, we'll go for formulas based on amplifier designs. Each formula we'll try to recollect in the class. How to practice the formulas. Next concept. Just I'll wait for 1 minute and I'll go for the next slide immediately. So write down quickly so the next slide we can complete. So nothing to practice much. The short notes practice it number of times so that they'll run in your mind for the practice session. The best thing that happen in our videos is each and every topic in workbook practice when it's taught, you have a short notes. That short notes you write like separate notes, whatever the content I have given. If you don't maintain the short notes separately, if you have a free time, you maintain short notes. For each topic I have explained for you, with patience I have explained each and every point. That short notes only you revise every time in analog electronics. That takes hardly very less time to revise the content of analog designs. Okay? It will be a good effect for you to do the problems. So let's see the next slide. Next slide we have is amplifier designs. Amplifier designs we have. So you can keep adding amplifier designs. In that one by one, we'll recollect the formulas. One is inverting amplifier we have. Inverting amplifier. In that, what are the formulas you have to remember is, first formula is AF is equal to simply minus R by R1. But this formula is valid when AD is high. We can use virtual ground so that this formula will come. AF is equal to minus R by R1 divided by 1 plus 1 by AD into 1 plus R by R1. So this formula is valid when AD is low. So like this you must get in your practice. Straightforward formulas. Second one, non-inverting amplifier. Second one is non-inverting formula. AF is equal to 1 plus R by R1. This is not non-inverting gain. Your closed loop gain will be 1 plus R by R1 divided by 1 plus 1 by AD into 1 plus R by R1. This is for AD high and this is for AD low. One is for AD high, one is for AD low. So these are the two formulas you can copy. Yeah, Sneha Kumari, just I came up website. You can note it. So these are my first two basic amplifiers, formulas. Okay. Next we have is formula number 3. That is a voltage follower. Voltage follower. This is inverting amplifier. This is non-inverting amplifier. So voltage follower, the formula is AF is equal to AD by 1 plus AD. When AD is low. This is the buffer formula. AF is equal to 1 when AD is high. Like this we practice the two formulas in buffers. Voltage follower we say this is. Voltage follower. The next we have is phase shifter. we have phase shifters. Phase shifter is nothing but your AF will become equal to minus 1. Straightforward answer. AF equal to minus 1. And coming to the fifth one, after phase shifter we have inverting amplifier. Inverting amplifier with a T network. How to practice this formula you can see, inverting amplifiers. So AF becomes, simply write first your gain. This is your inverting gain. First you write the answer. And in the practice here, it is 1 plus R3 by R2 plus R3 by R4. So what this practice is? Yesterday class we got 1 by R3 plus 1 by R2 plus 1 by R4. That R3 gone on the other side. So R3 by R3 becomes 1. R3 by R2 plus R3 by R4. This extra quantity you can have a link like this. R3 will divide by all resistors. So this is my gain formula for inverting amplifier with T network, which will give more gain. And coming to the sixth formula, non-inverting amplifier with T network. So the formula is something different here. It is 1 plus R2 by R1 non-inverting gain into the same quantity we have to write. 1 plus R3 by R2 plus R3 by R4 minus R3 by R2. So you can see the structure. How to remember this trick is, in this quantity, whatever you are seeing in the brackets, this quantity has to get subtracted here again. So in the non-inverting systems, that quantity will go as subtraction again. So this is about your formula practice. Okay. So sixth and fifth answers are similar to each other. Only thing is your inverting formula with the non-inverting formula. This remaining content is same, just you have to throw the answer with a negative sign for the last topic. And coming to the seventh one, differential amplifier. Differential amplifier. If anybody give this separate design like this, negative, positive, this is your output. This is R1, this is R2. This is R1, this is R2. So whenever you see the special design, differential amplifier, where equal resistors you are seeing above below. This R1, here also R1, this R2, R2. Then the formula you can practice for this is V0 is R2 by R1 into V1 minus V2. This is the standard formula we derived in the case of CMRR calculations. R2 by R1, just to keep it common, V1 minus V2 is called your differential amplifier output. So that formula should be a practice for it. R2 by R1 into V1 minus V2 is the answer. And this circuit will give CMRR infinite in the class. Okay, this circuit only can give CMRR infinite. CMRR will come as infinite for this circuit. We designed in such a manner, CMRR will become infinite. So these are your 7 practice formulas. 7 formulas are completed. The last slide will complete the final issues now. So one more slide to cover the concept. So please note it. Please note up to there. Just complete up to here. So if you have completed this, the last final touch, eighth formula we have is instrumentational amplifier. Instrumentational amplifier using 3 op amps. Instrumentational amplifier using 3 op amps. What is the formula for this? We have studied is your AD differential gain is equal to you got your V0 by your V1 minus V2 or V2 minus V1. Anything is okay. So it's equal to, you got some formula yesterday class. So what is that formula we got is 2R by Rx, you got some formula, correct? So answer you can write as 1 plus, we got 2R by Rx. This is the trick. This is an extra factor you got. 1 plus 2R by Rx means 2 resistors are in series, in the middle Rx is there. And we have this quantity, what we can write is your differential gain, that is R2 by R1. So this is the style. Your differential gain is R2 by R1. And we have 2 input non-inverting systems that has this quantity 1 plus 2R by Rx. Like this you can recollect the points. Without doing all derivations, this is a differential gain, this is due to the 2 op amp effect. 1 plus 2R by Rx. Rx is in the middle of 2 resistors. And coming to instrumentational amplifier. Instrumentational amplifier using 2 op amps. Today class only we covered this formula. It is 2 non-inverting systems we have used. It is V0 by VB minus VA we have taken is equal to, it is 2 times of 1 plus R by Rx, which is R by R1. R is high resistor, Rx is low resistor. This is the formula for it. So it is a cascading of 2 non-inverting systems. So these are the standard formulas we have to keep in practice. Ninth one, it is CMRR. In that AD, we got the answer as A1 minus A2 by 2. And AC is A1 plus A2. These are the formulas where A1 is a non-inverting gain, and A2 is an inverting gain. So A1 is non-inverting gain, A2 is inverting gain. So these 2 formulas are very important for practice section. And coming to the 10th parameter, we have gone to offset knowledge. In offset we have certain formulas again. V out offset formulas is 1 plus RF by R1 into VI0 due to input offset voltage, this is the formula. And V out offset, we have simply I bias into RF, this is another formula. And V out offset is I0 into RF. These are the three formulas we have to practice. Okay, these are the three formulas. And what is this R3? R3 is always equal to R1 parallel to RF. This is called bias compensation. Bias compensation के लिए R3 is R1 parallel to RF. And 11th topic we have is 11th one is slew rate. Slew rate formula we got it as AF Vm omega max. That is omega max can be written as slew rate by AF into Vm. If you want F max, we can write it as slew rate by 2 pi AF into Vm. So these are the formulas of slew rates we studied. Slew rate is a formula very easy. Lastly, we studied the gain bandwidth product. That is 1 into Ft will be equal to AD into Fh, and 1 into Ft will be equal to F into Fh of F, and AD into Fh will be equal to F into Fh of F. This is the total story, what we call from yesterday onwards. So this results will practice like this. Doing the problems will be fast in doing the concepts. Until unless if this will not come into your mind, doing the problems is not that much easy. Okay, you do it by using KVL KCLs, but shortcut you will not get it. That's the first have a hobby of getting each content like this first. So if you have a good practice, these all contents will go into your mind first. The short notes will be the best point to learn all these things. Just within half an hour, we covered all the issues of this big module. This is a big module actually in amplifier concept. Nearly 12 points in amplifier designs. We'll cover the total formulas, all the links for you in the class. So now when I'm doing questions, okay, each question may not take much time. Op-amps will take very easy and comfortable to answer the questions. Maybe one or in the workbook I've seen 3-4 questions are lengthy questions. Remaining questions are straightforward. We can do each and every question with the concept. So don't see the question numbers like that. By 1:30 I'll reach all the problems now. Target is 1:30. I'll cover the total video on this lecture. Okay. Correspondingly, you can note down. Otherwise, you can just tick the answers in your workbook. Whenever you have free time, you can see that video and you can practice. It is not required to copy in the notes. These are all solutions, whatever I do. Because the video will be presented for you. Whenever you want, you can see the video for the workbook problems. So I may not wait much time to solve each and every question. Okay? Just you can follow the question and see whether the concept is valid for that or not. Justify the answer, that is more than enough. Okay? Each and every question, just to justify the concept. So I'm going to start. Be ready with your workbook. First 5 questions are based on differential amplifiers. One time, read the questions and be ready with the answers. First 5 questions. If you have any doubt, you can go back and see the differential amplifier topics and understand what question is asking, what formula based on that. You can just recollect and you can see which answers are correct. 1 to 5 straightforward 5 questions based on differential amplifiers. First we'll complete that part and I'll come to the op-amp design questions. First 5 questions I'll complete first. Okay, let us start. Are you ready? 1 to 5 questions. Try to start doing the problems. First 5 questions. Read the problem, understand the answer for it. They will not take much time. 1 to 5 questions. Anyway, I'm starting parallelly with you. Let us recollect the concepts what we studied. So let us start with question number 1. This is a chapter 7 EC book. Don't get confused. Chapter 7 EC book mein karna hai. Question 1. Question 1 he said that a large value of RE in differential amplifiers will affect common mode gain or differential gain is asking. Which it will affect? Common mode gain or differential gain? Immediately you must get the formulas practice. What is the formula for AD balance, which we studied in our classes? It is a GM into RC. It is the transistor gain. GM into RC. In this formula, I am not seeing any RE. And AD, if you want unbalanced, easily you can recollect this formula also. It is GM into RC by 2. So these are called balanced gains and unbalanced gains. One thing is very clear that balanced or unbalanced gains, differential gains never depend on capital RE set. RE will get shorted in your AC analysis. So if you have any doubt, you can go back and one time see the score. So the recollection is more important. Okay. So I think that these are independent, I can say. These are independent. This is independent of RE effect. So don't touch AD concept. But AC, if you see unbalanced, AC unbalanced, the formula we have seen is RC by 2 times of RE is the answer. It's like unbypass system technique. So I think AC is depending on RE. If RE increases, your AC will get decreased. So I think the only story for this is it decreases the common mode gain. So I'm preferring here option D will be the correct answer. Option D will be the correct answer. So I'm expecting from you also answers. Okay, don't simply see the board. You just answer your questions. Option D will be the correct answer. Some students may do mistake also, no problem. Okay, then understand which option why I'm writing. Jahnavi said B. No problem. Mistake किया. B का answer क्या बोल रहे हो? It increases the common mode gain. You got confused with that. This is directly proportional. You are saying this is inversely proportional to capital R. So correct your answer. It will be D is the correct answer. D is the correct answer. Bose is telling second question 0 is the answer. Let's see what is the second question. Question number 2. Each question is based on formulas only. He's asking if RE is infinite. If RE is infinite, current source parallel is RE. The source resistance of the current source is infinite means RE is infinite. The common mode gain is asking. Is asking about common mode gain. Common mode gain AC formula is RC by 2 times of RE. So he said RC by 2 times of infinity is taken. So it will become 0. So second question answer 0 is the correct for it. 2A is the correct answer. So option A. Just by the basics of formulas we can complete these questions nicely. Completed questions are very comfortable if you know these 4 basic formulas. AC unbalanced formula is RC by 2 RE. This is our transistor formulas. GM into RC by 2. So first 2 questions are very convenient. Question number 3. Just catch the question number 3. In a differential amplifier, CMRR can be improved by using an increase. CMRR, if you want to increase, what to do? CMRR is nothing but GM into capital RE. Or we have another formula, 2 times of GM into RE. One is for balance, one is for unbalanced. Okay? One is balanced system, one is unbalanced system. Whatever may be, if you want to increase CMRR, the only thing I have to increase is RE has to increase. If RE increases, automatically your CMRR will increase. So I'm expecting option A will be the correct answer, called emitter resistance. Option A. We have to increase the emitter resistance to increase the CMRR. Fourth question. Question number 4. Question number 4. What is the data given in the problem is V1, V2, CMRR is given. What is the error in the output? First of all, what is error means here? V0 is, you can write ADVD plus ACVC. I said that my output can be written like this. Any op-amp output can be represented as differential gain into differential input, common mode gain into common mode input. But really speaking, this answer has to cancel. Only this answer I want. ACVC is an error for us. So shall we make this component ADVD? Just take the common. It is 1 plus AC by AD into VC by VD will come. So in this, can you see CMRR in the class? This is CMRR. So output you can write as ADVD into 1 plus 1 by CMRR into VC divided by VD. So what is the error here is? This is my error. This quantity always exists. If CMRR is not infinite, this quantity will exist. This will become your error in the output. This is error in output. Just calculate the answer, how much it is. That will solve your code. Error in output. Error in output will be equal to 1 by CMRR into VC divided by VD into 100% you take. Because he's asking in percentages, so you just multiply with 100%. So 1 by CMRR he has given by himself. But what is that VC VD? VC you can calculate it as V1 plus V2 by 2. And the VD you can calculate as V1 minus V2. So 1050 plus 950 by 2. It will become 1000 microvolts. This will become 1000 microvolts. And V1 minus V2. It will become 100 microvolts. So if you solve this one, I think it should get 1% should be the answer. So 1% you are expecting the answer for this. Fourth one, option B is correct. Option B is correct. So fourth question, option B is correct answer, 1%. Bose has already given the answer for fifth also, great. Fifth question is also similar question only. Just with this formula, you can solve it. Similar question. So question 5, V0 is equal to ADVD plus AC VC. Apply this formula. But AD is given, CMRR is given, AC is not given. Then what is the formula you can apply is AC is equal to AD by CMRR. With this formula, you solve this AC and just substitute and find out the answer. So if you complete this calculation, you have to get the answer as 164.8 millivolts. 164.8 millivolts. So option B will be the correct answer. So these are the 5 questions we have. Okay? These are the 5 questions. One more question is that is also a differential amplifier problem. Question number 6 is a theory statement question. They have given 2 statements for you. Whether the 2 statements are correct or wrong is asking. So justify that 6th question. A differential amplifier is used as input stage of op-amp is telling. Naturally, a differential amplifier with the input stage, correct statement. A differential amplifier will have very high CMRR, correct all. These 2 are correct statements. So 6th one. Here only I'll cover this total 6 problems. The 6th problem is telling, 6th problem. Statement A, differential amplifier is input stage of op-amp. Perfect statement it is. This is correct statement. And CMRR is high in differential amplifiers. Perfect statement. So I think both statements are correct. So option A you can take. 6th one, option A you can take. Most statements are correct. So like this, this is a set of differential amplifier questions we covered, which in the previous class we have not covered. Now in this class we covered this fundamentals. So up to here, I think no student will have problem. These all 6 questions nicely we can do it with the fundamentals. So next we are entering to the op-amps now, real op-amp questions now. Question 7, question 8 and question 9. Question 10. These 4 questions, एक बार observe करो. Question number 7, question number 8, question number 9 and question number 10. With my basics of op-amp, you can solve these questions. 7, 8, 9, 10, straightforward answers you can write without any problem solutions. No solution is required. 7th question, 8th question, 9th and 10th are very beautiful to complete. Question number 7, if you see, he has given an op-amp with minus plus, both are grounded, he has said. This is your output. He has given a batteries here. VCC saturation battery is 15, minus 15. And he said that there is some input offset voltage for this problem is. Now when we studied, there will be some offset voltage, 5 millivolts. Now he's asking, 10.4 is the AD value. So he's asking what is the output. You know that AD into VD is the answer. It is AD into VD is nothing but VS0. So AD is 10.4 into 5 millivolts. It is coming to be 50 volts in the problem. So output is coming 50 volts. But I said that in the class, output 50 volts cannot cross 15 volts. 15 is the highest. You said 50 volts. So I think it is wrong. And he has given the options plus or minus. So we'll take answer maybe 15 or minus 15. Because offset can be negative or positive. Anything can happen. So let us take the answer as saturation answers. So these questions are not required to do with tens. Only concept is required to do this. Very high gain system CAD values. Op-amps will always work in non-linear. I said. So it's working in non-linear. Straightforward answer. So answer is option C will be the correct answer. Option C is good answer for it. I think you are able to understand this point. 7th one, option C is correct. 8th one, can you tell with the basics what will be the answer for it? 8th one, if you see correctly the design. Minus plus. We have ground here. And we have resistor or some 1 volt he has given. And he connected positive feedback. And the batteries are given as 15 minus 15. This is the question. It's asking you what will be the output voltage from this circuit. If you are intelligent, you will not touch this question. You tell the fundamentals. What is the fundamentals I told? If any circuit which is undergoing with positive feedback, 100% sure that they never work in linear, they work only in non-linear because the gain is very high in positive feedback systems. So the answer should be, in the exam if they give 15, you take 15. If they say plus 15, minus 15, you take plus 15, minus 15. That means he is thinking that your input offset is positive or negative. Option say chalo. Okay. If they give only 15, then you write 15. If you say in the options, they are not given 15, only individual answers. They are given 15 or minus 15. According to the option you have to go. So you cannot say that sir I'll take only 15. ऐसे नहीं बात करना. In the exam only 15 देते answer is that is correct. Yeah. So a positive feedback, which is a positive feedback, will work in non-linear. This is 100% correct. Will work in non-linear. What is non-linear is output can be plus or minus 15 volts. You can see 8th question, he has given only 15. So you can take only 15 volts, which is called saturation. If the examiner says only 15, you write only 15. If they say plus or minus, then you take plus or minus. According to the option you take. Okay? In this question, he has given only 15. That's why I have taken 15. So completed without touching the question. 8th question is completed. 9th question. So this will be the option plus 15 means option D will be the correct answer for it. Question number 9. Carefully see that question number 9 one time. This is a very intelligent way of diagram. Can you write the same diagram like this? For understanding purpose, nicely, the same diagram I can modify it. Irregularly they have given. So how I write this diagram is, this is R1 here. This is your voltage. R2 can I write as a feedback point between output and V minus point. He has given like this actually, just I'm connecting in a proper manner. That is R2. And the R2 position is like this. And R3 is connected between V0 to ground. This is R3. So whatever the examiner given the circuit irregularly, I made it in a proper way. So if you see this diagram, it is just looking like our inverting amplifier concept. This is an inverting amplifier. So for inverting amplifier, what is your gain answer is? It is simply minus R2 by R1. So this is an inverting amplifier. So simply to confuse you, they have given like this. It's an inverting amplifier. If it's an inverting amplifier, it is minus R2 by R1. So you can take this as option A will be the correct answer. It's an inverting amplifier concept. 9th one. So Bose, you have said wrong answer here. Arpita is telling 9D. आपको क्यों इतने आंसर्स आ रहे हैं आपको? A diagram देखो. This is the diagram actually. Whatever he has given irregularly, I have written in a proper manner the context. Okay. So this only they'll try to confuse you. The question is simple only, but they are confusing you. You have written properly. In this question actually, R3 is load here. This is RF. This is R1. So the gain is not depending on the load. The gain is depending on RF by R1. So RF became R2. Okay. Yes. Output there is R3 means R3 is a load resistance here. That will not influence your gain. So that is the story here. Very good question. 10th question is also a simple question I think. Question number 10. Question number 10 if you see, this is a concept of differential amplifier. It's a concept of differential amplifier. And having R1 and R2, two resistors are symmetrically he has given the problem. 10th question is a symmetrical circuit which has CMRR infinite. So what is the output he is asking? For this circuit, can you recollect the formula? Can you recollect the formula? I think a 10th circuit the formula, I'll go back and I'll show you somewhere. I think this one. This is the presentation. R1, R2 is same. Then the formula has to come into a practice. R2 by R1 into V1 minus V2 is the answer. Okay, no problem, Arpita. No problem. So answer is simple. R2 by R1 into V1 minus V2. For the type of circuits, this is the formula. R2 by R1 into V1 minus V2. R2 is 10K by 1K. R2 by R1. Have you seen that V1, V2 both are same? Vi minus Vi, so answer will be 0. That means whenever you give common input to this type of circuits, they'll try to reject 100%. That's why CMRR is infinite for this circuit. So whenever this question comes, don't make any analysis. Straightforward you can write answer is 0 because both inputs are same. Okay? Both inputs are same. That is the standard concept. Option D will be the answer. Option D will be the correct answer for it. So up to here we completed 10 questions are completed. Next 11th and 12th is the next target. 11th question I think this is also an application we done in the notes. Just take recollect karo. 11th question is an application we got in the notes. Can you understand that 11th question is what application it is? Straightforward you can write the answer for it. 11th question. Anybody can tell what is the type of application we have used in the notes? तो सर्किट देखते समझ में आना. आज का क्लास मॉर्निंग when I started, this only I have started called instrumentational amplifier using 2 op amps circuit. It's an instrumentational amplifier using 2 op amps. Savneet has said the point. Good. It's an instrumentational amplifier using 2 op amps. Then we should not do calculations. I said straightforward. You have to complete the answer. If it is question number 11, if you can recollect that it's an instrumentational amplifier using 2 op amp circuit. The formula is very easy. I said it's a 2 non-inverting gain formula. So he's asking only V0. I think he's asking. So V0 formula will be it is 2 times of 1 plus R by Rx. That is a 2 non-inverting and 2 times multiplication. VB minus VA. If it gets like this, hardly 10 seconds this problem will be completed. So 2 into 1 plus R is given symmetrical resistors is 2K. All are 2Ks, but Rx is given as 1K into VB. 2 minus 1 difference. So answer is you can say 2 into 1 plus 2 is 3. So answer is 6. See how much time it has taken for me to solve this. Otherwise, if you don't have the type of knowledge, there's an instrumentation amplifier, there's a formula for it, then I think it takes a lot of time to complete in the subject. So they're all standard things. You have to recollect first what application it is, what is the formula behind it. Then I think the person will solve this in seconds actually. The answer is 6 without any calculations. Okay, that is the advantage of op-amps. Standard questions go easily. So option A will be the correct answer. Option A is good answer. Okay, and next question is a confusion problem for the students. Okay, already electrical students, this question came 2 times. Easy students also you got. This question has some logic. That logic will understand. Question number 12. In this question, what is the confusion for the student? See here, he has given here a voltage of 2 volts. Next he has given us 5k resistor. The next op amp is there, minus plus, and you have 10k to the output. This is 10k, and we have here a resistor that is 100k, and we have 10k. The only problem for the student when you see this question, he'll get only the problem is whether positive feedback you have to take or negative feedback. So both the things you are seeing. Yes, Arpita, easy. These all questions are very easy. So you can see both the feedbacks whenever you have. Only one logic I want to tell you. Whenever the person has given some input like this, remember the point. It works like an amplifier. If you give positive feedback also, it works like an amplifier. That means it works under negative feedback. So the logic here is, so whenever negative, positive at a time, when negative, and positive feedback is connected with input, with VIN, input is there. Without input you should not say. With input, then negative feedback will dominate. This is the rule. So simply you can use the concept of V plus is equal to V minus. This rule you can apply to finish this problem. Okay? Input should be there compulsory. If input is there, it works like an amplifier. So positive feedback also you apply, it will not disturb the system because negative feedback will dominate it. So I think first you find this answer by this positive feedback. It will be V0 by 11 is coming. Voltage division rule you apply, find out that answer. According to virtual ground, you keep here V0 by 11 and you take this current name as I1, this current name as IF. Just one step answer. For KCL, if you apply at V minus, is I1 is equal to IF. You solve this problem. It is 2 minus V0 by 11 divided by 5k should be equal to V0 by 11 minus V0 divided by 10k. So with this, I think V0 is unknown in the class. Just one KCL, you find out the V0 answer. Just a virtual ground you can apply it. Rahman, if VIN is it inverting also, non-inverting also, wherever it may be. Okay, negative feedback, whenever you have, negative feedback will dominate the positive feedback. Input should be there compulsory. That point please remember. Okay, if input is there, what happens? It works like an amplifier actually. That's why negative feedback will dominate it automatically. In the next class, tomorrow or some class, we don't give any input on both sides, but positive feedback, negative feedback will apply. If no input is given, then positive feedback will dominate the negative feedback at the time. So these are the rules actually. Somebody does here positive feedback, negative feedback input नहीं any one side you have to give the input. I already given the input here or not? इधर भी देखो एक input चाहिए वो बोल रहे इधर input नहीं है इधर input है. But this feedback point will give the voltage here. Positive feedback ये voltage दे रहे हैं. That voltage became my virtual point. So answer is minus 5.5 will be the answer. So answer is minus 5.5. Option D will be the correct answer. So option D you can take. Okay. Yeah, Samresh, your statement is good. If input is present, negative feedback will dominate the positive feedback. These are 2 marks questions given number of times this question. So don't get confused, simple logic it is. Next, the 14th question is a normal question. Everybody can do it, I'm expecting. It's a cascading of 2 amplifiers. So complete the 14th question. 14th, 15th, 16th, 17th, 18th, 19th, 20th. These are all questions every student can do it with the formula space. So up to 20, you can do it. I'll do it parallelly, you just check your answers. Up to 14 to 20, you can cover yourself the questions. Without my help, you can do it. First, to try to start 14th question. Okay? Question number 14. Question number 14. This is your op amp, minus plus. So you have here 1 volt. And top side we have some resistance. This is 1k. This is 1k. This is minus 2 volts. And we have op amp again, positive, negative. This will be output V0. This is 1k. And this is 1k. This question is a very simple question. Everybody can do it. The first one is a differential amplifier. It is DA. Differential amplifier it is. The second one, you are giving input here, which is coming some Vx as an input. So it's a non-inverting amplifier. So we have to do in 2 steps. First complete the part 1, then complete the part 2. Okay? Part 1 complete कर दीजिए. First year result find out करो, then apply to this, we'll get the answer. First differential amplifier, story is Vx. Superposition theorem, you can solve it. First non-inverting is 1 volt into 1 plus 1k by 1k. This is the story number 1. Minus of minus, it will become plus 2 into 1k by 1k. So answer will be 2 plus 2 into 1 is 2. To 4 volts we are getting Vx. Up to answer 4 volts are differential action set. So if this is 4 volts, then apply this concept. So what is V0 here is 1 plus 1k by 1k into Vx. This is a non-inverting gain. So answer is 2 into Vx. So 2 into Vx is 4. Answer is 8 volts. So it's a very simple question. Option C will be the correct answer.